Let's work on finding all the possible triangles when we're given this information. The one side has a length of 4, opposite this angle of 50 degrees, and a second side has a length of 10. So when I get going on these, I always try to just draw myself a quick triangle. It doesn't have to be to scale by any means. Label some sides, label the angles. That's the traditional way to write these. Now, they didn't tell us what was alpha, what was beta, any of this. So we just kind of have to label it based on the information we're given. We know an angle is going to be 50 degrees. I'm going to put that on alpha's corner. It doesn't really matter which corner you put it on, as long as the side opposite that is going to be 4. So A in our situation, because it's opposite of the 50 degrees, is going to be 4. So it's going to go for A. And a second side length is going to be 10. I'm going to put that as B, but it really doesn't matter. You can put that as C. It would work just as well. All right, now, as we want to set this up, the only obvious thing that we want to find next is going to be angle beta. Now, why I say that is we know an opposite pair. We know a side length and the angle opposite that. That's pointing us towards the law of sines. Also, we don't know this is a right triangle, so we're pretty limited on what we're allowed to use in this situation. So I'm thinking about finding angle beta. So I'm going to set this up as sine of beta over the opposite side length. So in this case, B is going to be 10 equals sine of 50 degrees over the opposite side length 4. Now I'm working on this. I want to isolate the sine of beta next, meaning we want to move the 10 to the other side. So we can move it over there by multiplying both sides by 10. That'll get a sine of beta on one side by itself. You could reduce down. I'm just going to move that 10 out in front because it is in the numerator. And we're at this situation where sine of beta is on one side by itself. Now we want to get beta out from inside of the sine function. So the next thing to do is apply a sine inverse to both sides. So sine inverse arcsine gets applied to both sides, and that's a one-to-one function, so that should be okay. And then we want to know, by putting this into our calculator, what do we get for beta? So when you put this in your calculator, you're going to get an error message of some sort, okay? Different calculators tell you different things, but there is going to be some sort of error message saying this doesn't work, all right? So this is going to turn out being a no solution case. But you may be wondering, like, why? How do I know this is going to be no solutions? Besides just, hey, I input things in my calculator wrong all the time. How do I know I just didn't make some other sort of mistake along the way? Well, if you kind of ignore the sine inverse on the outside here, let's go back to when we just add sine of beta equals what's on the inside here, the 10 times sine of 50 degrees, all divided by 4. If I were to just put that part in my calculator, I would get 1.915 ... right? That keeps going. So it's back before I applied the sine inverse. Well, when can we plug in some angle into the sine function and it's going to output a 1.9? Well, that's never going to happen. And why it's never going to happen is we kind of think back to our sine function and what the graph of that looks like. That's the graph that kind of oscillates back and forth here. And the highest value it attains is 1. And the lowest value it attains is down here at -1. So we're trying to figure out when is it going to output a 1.9. So that would be way higher than the highest output value for our sine function. So that's why this can never, ever happen. There's no angle we can plug in here that's going to output a 1.9 or anything bigger than 1. Or anything smaller or more negative than -1. So I hope that helps out on why this gave us an error message. And this is going to be a no triangle can be created case. So I hope this helps out. Good luck with law of sines and non-right triangles.